I'm CK. For today I reached into my bag of Mitch Electronics kits and I pulled out 555 timer based monostable circuit, and because they're so small and because Mitch Electronics is thoughtful like this, we've got a through-hole version and a surface mount version, and I will be doing both of them in this video. If you want to watch both, watch the whole thing. If you want to watch just one or the other, you can skip to that section with the chapter markers, and I hope you enjoy the video. Here's the two bags. We've got the monostable with through-hole parts here, and the 555 monostable with surface mount parts here. Let's open up the through-hole one first, and where did I put my scissors? Let me go find them. Now, 555 timers are both ubiquitous and very valuable in many things. They're not really timers per se. They're used as timers, but you can go look them up. Again, the best thing to do is go look up a page on 555 timers as bistable, astable, and monostable oscillators, and you can see why they're so useful as timers or even tone generators, even though they are not as precise as a real timing circuit, a dedicated timing circuit. But they're very important. I'll try to link something in the description. Take a look in the description for a good example, unless I forget again, like I usually do when I say I'm going to put something in the description. So here is the through hole. 555 monostable, Mitch Electronics 2022. R3, R2, R1, a switch, the IC, which will be the 555 chip, the big capacitor and small capacitor, inputs, so it may actually send the trigger signal from the 555, I'm not real sure, and then the variable resistor and one LED, probably to show us what state the oscillator is currently in. And we've got a nice, this is a 1K, I think. Be nice if it was labeled. Yes, it's 1K. And a 204. Battery snap cap. Our big capacitor at 100 microfarad, 16 volt. So the 555, whose is he using? I don't know that manufacturer. Little tactile switch, little IC socket with some seriously bent pins. So we'll get those fixed up real quickly with my needle nose pliers to get them all back in alignment. And a couple of resistors, and we don't know where they go specifically, even though we could probably figure it out. But there's a QR code for the instructions, which will be taking us to what I am assuming will be another really good Mitch Electronics web page that'll describe how it works, give you a good schematic, even have a simulator. Many of the pages have a simulator, so you can see what's actually going on once you get this together. Very useful. So here's the surface mount collection of parts. And we've got to make sure I got everything out of there. Put that to the side. Battery snap cap again. We've got, what do we got? Oh, we got a bunch of LEDs. He does occasionally pack extras in his surface mount kits. So it looks like we've got 5 LEDs here. Then we've got like 2, 4, 6, 8, 10 100 nanofarad capacitors and resistors, 100 ohm, 1, 2, 3, 4, 5. I mean 10, I was counting by twos, sorry. And then 2, 4, 6, 8, 10, 1K resistors. So we've got lots of spares. And then here's surface mount electrolytic capacitor. 100 micro, though it's only 10 volts, the other one was 16. Here should be the 555 chip itself, and it is. The pitch on the little legs is just fine for surface mount, hand surface mount. And here, what do we have here? Oh, this is the rheostat, or I'm sorry, variable resistor. It's in a tiny, tiny package. I don't think I've used one of those before. Interesting. And let me double check. I don't think I have done one of these before. Well, I'll be learning something today too. And here's the circuit board, obviously or clearly. Using surface mount parts allows you to shrink your package size quite a bit. And we've got the variable resistor, the capacitor, resistor, diode, resistor, capacitor, chip, switch, and another resistor, and power in and out. This one does not have, this circuit board does not have the trigger output, or out and trigger, which the through-hole one does, which is kind of interesting. Just power. So that's all the bits and pieces. I'll get the soldering iron heated up, get the build guide up, and we'll put these two things together. I was about to say in the comments which one you want to see first, but by the time you comment, I will have already made my decision. Haven't made the decision yet, so I will keep you in suspense. I decided I'll do the surface mount version first tonight, and in prep for that I got my Chip Quick rosin paste that I use for the IC legs on when I'm doing surface mount, and I have my MG Chemical 0.025 diameter solder, the thinnest I can reasonably work with. My iron with its my soldering iron, which its 0.03 tip, is just fine for this. So what I'm going to do is I'm actually going to bring this over here and, oh, I forgot to pull up the build guide. I am so silly. Get the QR code, tap on it, and it will take us to the SMD trainer page on mitchelectronics.com. Here we have the schematic, battery, the resistors, the trigger, the capacitors, all to set the timing of the 55555, and then the LED, which will show us the output. Then a nice layout of the circuit. To help keep the board stable when soldering, you can download a free 3D printable jig. I'm not going to do that because I don't have a 3D printer. This is interesting. It does not have, on this one, it does not have the simulator. I'm gonna go ahead and see if he's got it on the page for the through-hole version. He's got it, yes, and he's got the simulator here, which is basically, it's the same for either the through-hole or the surface mount version. So if you've got the surface mount version and you don't have the through-hole version, then go to the through-hole page and you will be able to see the way everything works in a simulated form, which is really nice. But for now, we don't have an actual build guide, but we do have a schematic with the various parts identified. So we know R1 and R1 is a 1K, R3 is a 1K, R2 is a 100K, and there's the variable resistor. So we'll be able to figure all this out. Now what I'm going to do, I'm going to take the top camera off autofocus. I'm going to zoom it in. I should always tell you before I zoom it in. I'm going to take it off autofocus and focus it in out there. I think that's about it. I think that's about good. So my hands will go in and out of focus, but the circuit board will stay the same. So what the author of the kit recommends is we do the IC first, and I am certainly in sync with him on that, though I do have to say he doesn't have the board marked for where he wants to, oh, he doesn't have a dot on the board indicating where the notch or dot on the chip is, so I'm going to be guessing here, even though I should be able to figure it out. We've got pin 3 going off to R3, so we know pin 1 is here. Peeling the plastic back on this. Gonna drop that out on the board, and you can see there's a little dot there which will go on this side. Let me see if that's similar. Yeah, and it's similar to what he's done here, even though the layout is, you can't really follow exactly what the layout is. Now, what I'm going to do first, what I do, and many people do, but it's my technique that I use that I've been successful with, is I'm going to get the solder out from under my iPad and solder pad, and I'm going to put one dollop of solder on the pin 1 pad, like so. Now I'll get my surface mount tweezers. You always want a good pair of tweezers. I did a video about tweezers about 2 years ago now, and you can look at that and read my thoughts on tweezers you need and suggestions on which ones to buy. The ones I have are not very expensive. They were just a good set from Amazon. Now I'm going to move, I'm going to take a look so you can see what I'm doing. Yes, you can. I'm going to move the chip like so and grip it with my tweezers. Then reheat that solder I just put on that dollop. Let it cool, and the chip sinks in, and all the leads are over pads, and because I've already got one leg soldered, I don't have to worry about it moving around on me. Now I'm going to take some of my Chip Quick solder, pull some up on my pointy thing. I pulled up quite a bit, but you know, this little 3-ounce or so tin of Chip Quick, it's not a tin, it's plastic, for crying out loud. It's 2024 for crying out loud, is going to last me a very long time. Now with that extra flux there, that flux will keep the solder, hopefully, from bridging between pins, and it'll just go on the metal pads, as you can see here. That looks good. You'll notice I kind of put the tip of the soldering iron between the legs of the IC. That's my personal style. You may want to, depending on what soldering tip you use, you may have a different way of doing it. It's one of those things, because it's a technique. There is no correct way to do it. The correct way to do it is the way that makes you successful. And if you have a different way of putting your solder on or your whatever, and it works for you and you get successful results, well, I would say that's the right way to do it, huh? You know, it's just like there's some loudmouth electronics bloggers and video YouTubers who say, if you don't do this, you're wrong, or if you use this, like if you use a specific kind of soldering tip, you're a fool, and that's just dumb. I mean, use what works for you. It's good. So that's the hard part. I mean, actually this variable resistor is probably also going to be a hard part because I haven't done one of these before, and it's a really tiny part, and I don't know how far out the leads extend. So I think I'm going to do that next, and I think I'm going to use the top connection first, and again a little piece of solder on it to get the positioning right, and I'll pick up the variable resistor and turn it around so it's oriented correctly. And I don't know, sorry, I'm looking at this. And same thing, we heat up the solder pad even though that's not flat, so I'm going to heat it up and let it flatten out. Now, let me look at the other ends and see if I can get solder under those. I think I can, even though I'm going to slide this up just a little bit. To give me a little more. See, now we've got a little more of the solder pads showing, and it may have risen up on me, so I'm going to let it sink down again. There we go. And you may be wondering why I'm not putting solder on all the pads and then doing it. I find that when I try to do that, it rocks, and I have an unstable work surface, and doesn't work for me. Again, it might work for you really well, because that's of course what you would be doing if you were laying out solder paste for actual doing a reflow with heating pad, hot plate, or a reflow oven. I think I got both of those in there. Actually, I think I got this one. I don't think I got this one. Did I move my light into the camera? No, I did not. Good. I just had to move my light so I could see better. There we go. Give this one a little more love. There we go. Now that the two hard parts are done. So next, I think I'll do this capacitor. And again, other people certainly would do like you would do, like I normally do on a through hole, and put all the resistors on first. But I kind of like to do it this way just because it's a way I'm comfortable with. Now this time I'm just going to do the one. I have a little bead of solder here that I want to pick up. There we go. So this is the positive side, and that's the non-striped side. Now we'll do the resistors, and R1 is 1K, So I'll go to my little 1K strip and very carefully take one of the 1Ks out, which is easier said than done. Again, like I always like to say, these paper tape component things are for machines to get the parts out, not for clumsy human fingers. The good thing about this kit is you end up with lots of spare surface mount components. So there's 1, 0, 2. That's the number that's written on there, and that means it's a 1, 0 with 2 more zeros, so that means it's 1,000 ohms, or 1K. Now, I personally like to put the values up, because the other side of the resistor is blank. You don't have to. Electrically it'll work just fine either way. I just like to do that so if I've made a mistake, I can find it easier. Now, you think about that, what I just did there, that's actually a little quicker than doing a through hole, because I didn't have to mess about with bending legs or clipping leads. So once you get reasonably good at through hole soldering, surface mount soldering, you'll find that it can be pretty quick. You just got to do the prep well and things like that. Now, I think I'm going to do this diode next, and I want to take a look here to see if he's got an indicator. He, again, does not have an indicator as to where the cathode is, but I believe it's on this side based on the fact that, looking at the schematic, if you're following along, pin 3 output is going to R3, is going to the LED, and we've got R3 line to the LED, and then the other side going back around to pin 5. Now for the diodes, LEDs, and other diodes, but in this case it's just a single LED. I'm going to take that out of its packaging. I knew it went somewhere, I couldn't see it. Now, I don't know if you'll be able to see this, but there's a green triangle on the back of the LED, and the green end, you can see one of this leg has a green end, this leg does not, and the green end goes on the cathode side. I think that's going to be good, but I'm going to check it. Yeah, you can see with my probe set in continuity mode, I'm getting it right, and I haven't bridged anything. I was a little worried I might have bridged underneath the component, and I didn't, so I'm going to put a little more solder on this one end. Now we'll get the switch. Where is the switch? There it is. Should I do the switch first or the capacitor? I'll do the switch first. Same drill, because part of the decision as to which component you're going to place first or second or third. In through hole, you're doing it by height. For me, on surface mount, it's all about what's going to be the easiest path for me to get the soldering iron to it. Because if I had put the capacitor on first, I would have a little trouble getting at this leg of the switch without hitting the capacitor with the iron. On through hole, of course, you're just working with the wires on the back side of the circuit board, so it's not an issue. See, I probably should have done the switch right after. Had I been thinking, I would have done the switch right after I did the 555 timer chip. I really do have to stop calling it a timer chip. It's not really a timer chip. It's a counter chip. Okay, now we're going to do the capacitor, and it's a 100 nanofarad, and only the one. And I'm going to put solder on that pad. And for reasons that I don't know, surface mount capacitors don't have their values printed on them like the resistors do. And I don't know why that is. I've never looked it up. I've always just wondered about it. There's all the surface mount stuff on. So I will just kind of shove the battery leads through here. I could do it that way. I'll do it that way just to make it a little bit neater. And now let me go get a rechargeable 9-volt battery. Okay, so I got one of my EBL rechargeable batteries. I like EBL, I don't know why, they just work really well for me. So I'll plug that in, and I gotta remember to refocus, manual focus, so hold on a second. There we go, that should be good enough. Now what's going to be happening is we're going to trigger it, the LED will go off, will light up, and then it will stay lit a variable amount of time set by this capacitor and this variable resistor. So I think I've got the variable resistor all the way to one side. So we'll trigger it, and there the LED comes on, stays on for a while. This would be like for using a badge on a card reader, and then it goes off, sets a delay time. 1 and 2 and 3 and 4 and 5 and 6. So that was about 6 seconds. So I'm going to change the resistor completely the other way. I don't have a good screwdriver for this, so I'm using my needle noses to rotate it around, which is not optimum, of course. So that's completely, or pretty much completely the other way, so we'll trigger it. 1, and, ooh, that went out very quickly, less than a second. 1, and see? So changing the value of that resistor is going to change the amount of time that the current and the circuit is active, which you can, I'm sure you can think of a bunch of handy little places where that might be useful. So that's a monostable 555 chip demonstration. Now we'll do the through-hole version. Let me get set up for that. Now we'll do the through-hole version, and again, the through-hole version web page is a little more complete. It's got an interior view of a 555 timer, so you can see the voltage divider and the two op amps inside, and all the pinouts, and the regular schematic, of course, and again the simulator and how it works, and then a component list with actual positions on it, so we don't have to just read the schematic this time. So this one's a little more complete, but again, the surface mount was straightforward to do, as you saw. And I will, again, I'll do manual focus up here. Hold on a second, it'll go in and out of focus a little bit. And there we go. Now it should stay in focus on the board. And now we are going to do it the regular old way. We're going to start with the resistors. And we've got two 1Ks and this is missing one. The parts list, component list is missing one of the resistors. Oh no, they're all the same. I'm sorry. I thought they were they all the same on the other one? I don't think so. There was 1K and then 100 ohm. Huh. So that is slightly different. But we'll put R1 in first. And give that a quick solder to see what it feels like. Where is a piece of solder? I'll use some of this 025. I'll have to use more of it. But that goes together well. The traces are a little easier to see on this board if you want to follow the current flow, or signal flow, I should say. So I'll put these other two on, but I'm not going to solder them right yet because there are so few, not enough time for resistor time. So I'll just poke them on through and then get the socket. Socket has a notch that matches the notch on the circuit board, as one would expect. Printed on the circuit board, that is. And I will solder these pins. I'm just going to solder everything up now. There's those fellows all soldered down. Now we'll take the ℉ nanofarad, the 104 decoupling cap, will go in C1, which is, where is it? I'm sorry, it's going in C2. C1 is the electrolytic. That goes in there like so. And the electrolytic, which I'm going to be cutting out of the paper, I always cut them out. I don't try and bend them out or tear them out, because that trick never works. It's a plus sign and a shaded sign. The plus sign goes with the longer lead, which we of course cut off, but the shaded side is the negative side, shown by the gray stripe on the electrolytic, so it's easy to figure out. You've got two ways to determine on most electrolytics what you're doing. A long lead for the positive and a gray stripe side for the negative. I'll go ahead and set the switch in place too. We're just going to rollick and frolic through this. And we'll put the LED on, and the LED, again, long leg positive, going through the thing, the hole marked positive with a little plus sign. We'll solder all these fellas up. And the switch, did I get all those? I didn't. The switch is a little cattywampus. So push that back into place. Now we'll put the 100K pot on, and the shaft faces outward. And obviously I don't have it straight right now, and I don't care. I'm going to solder one of the pins, let it cool a little bit, then straighten it up while I heat the solder again and let that cool. And now it's as perpendicular as I care to have it. And then one more thing, we're going to put our positive power lead in on top and a ground lead in beneath it. Grab this piece of solder from outside, from underneath our iPad. Now we'll solder all the rest of these little fellas. Flip it back over, and we're going to put the IC in the socket. I'm going to bend the legs in a little bit against the side of my workbench. Match the notch to the notch on the socket and the circuit board. Make sure I've got the pins going in the right place, and I do. And there we go. So that was, as you noticed, quite a bit faster. Now, we'll power it up and do the same thing we did with the other one. See how the monostable decays with varying resistance. Let's turn her on, and it goes away right away because I'm all the way counterclockwise. Let's go about halfway up, and it's decaying, the capacitor's bleeding off, and it goes away. A little more resistance, and it'll 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9. 9 seconds worth. So now you see how a monostable oscillator works with a 555 timer. You can take a look at the schematic and the flow against the simulator that he includes on the web page, and you'll know more than you did before. So that's it. 2 little kits from Mitch Electronics. Good documentation and a good kit, and we got both surface mount and through hole practice on this one. And I hope you enjoyed the video.